Here I must find the equation given this exponential function. So to start off, I know that an exponential function kind of follows this y equals a times b to the power of x, and then this k value is giving us the asymptote. So really the first thing that I can do immediately is that k value is really shown by the asymptote, and I see that the asymptote here is at -6. So I already found one of the variables that I need to find. I'm given 2 points, the blue one and the green one, so I'm going to actually plug those x and y values into this purple equation here. So my first one, starting from left to right, is the y value of -5. I don't know a or b yet, and my x value is 2. Whereas for the second point, my y value is 3, -3, I mean, and the x value is +3. So I just plugged in both of those x and y values, and now I can kind of see this as like a system of equations where I can use substitution to go ahead and solve for that. So first thing I'm going to do here is in the blue equation here, I'm going to solve for a to make things nice and simple here. So I add 6 to both sides. 1 equals a times b squared, dividing both sides by b squared to get that a value alone, and I see that a is equal to 1 over b squared. Now this is important because I'm going to plug this back in to that second equation so I can solve for b. So in this one here, I'm going to have -3 equals 1 over b squared times b cubed. And just to make that look a little bit prettier here, I got -3 equals b cubed over b squared minus 6. And now from here, b cubed over b squared simplifies to just b. So -3 equals b minus 6. I add 6 to both sides, and my b value is 3. Which makes sense because when I look at my graph, I can tell it's exponential growth, which means that my b value should be a number greater than 1. My last step here is taking that b value and plugging it back in to find my a value. So my a value is going to be 1 over 3 squared. So my a value is just 1/9. And my final equation, y equals 1 over 9 times 3 to the power of x minus 6. And that's my equation of this graph.